This is a video from section 6.4 in a Calculus 2 class, and we're going to take a look at number 15. A cable weighs 2 pounds per foot, is used to lift 800 pounds of coal up a mine shaft 500 feet deep. Find the work done. And so we have, notice here, we have 500 feet of cable right here, and we have 800 pounds of coal that we want to lift. Okay, so there are two different works in play. We need to find the work required to lift the coal, and we need to find the work required to lift the cable. To find the work required to lift the cable, I'm going to take a look at a small piece of the cable of length delta x, and I want to find the work required to lift that small piece of cable. And so I want to place the 0 at the bottom of the cable with the positive direction going up. We still need to place the 0 in these problems, just like with the pumping water problems. Okay. Now, what we're going to do is let W1 equal the work required to lift the coal, and we're going to let W2 be the work required to lift the cable. So let's take care of the coal. W1 is going to equal 800 pounds, remember pounds is a unit of force, times 500 feet, because it's 500 feet deep. And when we multiply those two numbers together, we get 400,000 foot-pounds. And that's the work required to lift the coal. Now we want to find the work required to lift the cable. And so to find W2, we look at a small piece of the cable of length delta x. We want to find the work required to move that piece of cable. And so notice here, I have a small piece, redrawing this, of length delta x. And suppose x is the distance from that small piece of cable to the bottom of the cable. And what that tells me is that 500 minus x is the distance from that small piece to the top of the cable. So we're going to need that shortly. The cable weighs 2 pounds per foot. So the weight of the piece of cable is 2 pounds per foot times delta x feet. And 2 pounds per foot times delta x feet is 2 delta x pounds, because notice how the feet cancel. Now, work is force times distance, right? So we're trying to find the work required to move that small slice of cable. The force is 2 delta x. The distance that that slice moves is going to be 500 minus x. And so rewriting this, we get 1,000 minus 2x, that quantity, times delta x. So W2 is the integral from 0 to 500 of 1,000 minus 2x dx. And integrating, we get 1,000x minus x squared, evaluated from 0 to 500. And when we replace x with 500, we get 250,000. And when we replace x with 0, we get 0. And so we get 250,000 foot-pounds. Okay. And W is W1 plus W2. So it's the work required to move the coal plus the work required to move the cable. And so that's 400,000 plus 250,000, which is equal to 650,000 foot-pounds. And that's going to conclude this video for section 6.4, where we looked at problem 15. Thank you.